Hi, I'm Susmita Rai, roll number 18NS0027 from Ramchi Government College. I'm here to make a video for the partial fulfillment of BSc Honours on Physics at 5th SEM, which carries 25 marks instead of 25 marks practical exam. Before beginning my video, I would like to thank Department of Physics and Dr. Sipi Khatiora of our College of Sikkim University to provide me such a wonderful platform to make a video. My topic is 8085, that is 8-bit microprocessor. Before going to the depth of 8-bit microprocessor, first let's talk about what is a microprocessor. A microprocessor is an important part of a computer architecture without which we will not be able to perform anything on a computer. It is a programmable device that takes an input, performs some arithmetic and logical operation over it and produces the desired output. In simpler words, a microprocessor is a digital device on a chip which can fetch instructions from a memory, decode and execute them and give the further results. Microprocessor performs three basic things while executing the instruction. Number one is it performs some basic operation like addition, subtraction, multiplication, division and some logical operation using its arithmetic and logical unit, that is ALU. Data in microprocessor can move from one location to another. Number 3 is it has a program counter PC register that stores the address of next instruction based on the value of PC. Microprocessor jumps from one location to another and takes the further decision. Now let's talk about how this 8-bit microprocessor was introduced by Intel. So in computer architecture, 8-bit integers, memory address or other data units are those that are of 8-bit bytes. Mainly we can consider 8-bit microprocessor means 8-bit data or the information bus. For controlling a CRT, that is cathode ray tube display, Federico Fagging and his team at Intel designed a chip produced by a Computer Terminal Corporation. Later this chip was called as a data point. This chip did not meet the data point functional requirement of speed and they decided not to use it. World first 8-bit general purpose microprocessor 8008 was first developed in the year of 1972. The Intel 8008 was used in the famous market computer kit. On realizing the potential of this product, Intel introduced the improved version of 8008 and the respective architecture was known as the 8080 microprocessor. The 8080 microprocessor was introduced in the year of 1974. The Intel 8080 really created the microprocessor market. Along with the improvements of the integration technologies, the 8224 clock generator and 8228 system controller chips got integrated and implemented by Intel, which was required by the 8080, that is along with the 8080 microprocessor within a single chip, that is the Intel 8085 was finally introduced in the year of 1976. So now let's talk about the features of 8085 microprocessor. So the first features of 8085 microprocessor is that it is a 8-bit microprocessor. So why would we call this as a 8-bit microprocessor is because its data bus or data size that it can carry at one time is of 8-bit. The address bus is of 16 bits. Any address bus size can define how much a microprocessor can access to a memory. So here on the screen you can find the calculation of 2 to the power number of address line. So by calculation we can find the value of 65,536. We can approximately write as 64 kilobyte. So therefore 64 kilobyte of memory or microprocessor can access. This microprocessor is 40 pin IC package. That means the IC pin chip that we get is of 40 pinouts. This microprocessor uses 5 volt DC supply for its operation. Its clock speed is about 3 MHz. 8085 has it now as a 80 basic instruction. That means it is a length of instruction and you have 246 opcodes. Before we discuss about the programming of 8085 microprocessor, we need to understand about its hardware model. We will know about the components of 8085 microprocessor which we can use as a programmer. So what we observe here in the screen is this block. Everything that contains in this block are of 40-pin IC. Main components are only highlighted here. The first thing we find here is a accumulator. Accumulator is nothing but a 8-bit register. This temporary data results in the storage. ALU stands for Arithmetic Logical Unit, which means every arithmetic logic operation that we need to perform by the microprocessor, it is performed by the ALU. Then we have flags. Flags tell us the status of results. Status, like for example, when we add two numbers, what is its status, whether the outcomes is 0, positive or in the negative form. So all this status we will know from the flags. Then another component here is the instruction decoder. The work of instruction decoder is that whatever instruction that comes in the microprocessor from outside the memory, it converts them into the binary language. It will decode and understand the uses of binary language. So what we see here are the register array. We talk about the register, that is accumulator. We store the results or data. Likewise, we have another register as well under microprocessor, because sometimes we will have 4 to 5 numbers to temporarily store. Then we have a memory pointer register. Outside this block, it can access 64 kilobyte. So that means 64 kilobyte we can find in different memory chips, combination. In order to complete the 64 kilobyte, we need 32 kilobyte of two chips. Whether it is getting the data from one chip or from another, the information is given by the memory pointer register. In other words, memory pointer register fetches the information from which chip number it is collecting the data. Outside the IC blocks, we will get pinouts, which is categorized into the three. We get unidirectional 16-bit address bus. When we need to bring the instruction from one chip, so that means in which layer of the memory chip the instruction is stored, the layer has an individual number which we will call as an address. The memory layer has its own address similar to as of our home address. So those address is carried by this 16-bit address bus, and it will give information to the memory location. And the data is further brought back to the microprocessor by 8-bit data bus. In simpler words, by address bus we came to know where our instruction is stored, and data bus bring back the data to the microprocessor for the processing. To control all the signals, we can see a block of timing and control signal. The clock generator will give pulses to this block in which how much microseconds or time that is needed by any action to take. So from there the control signal or the control bus will come out. Whether to in signal or to out signal, the control bus will tell. Now let's talk about the programming model of 8085 microprocessor. The 8085 microprocessor model includes 6 registers, 1 accumulator, 1 flag register. In addition, it has 16-bit register, the stack pointer and the program counter. At first, let's talk about the register. The 8085 has 6 general purpose registers to store 8-bit data. These are identified as B, C, D, E, H and L as shown in the screen. They can be combined as register pairs B, C, D, E and HL to perform some 16-bit operation. The programmer can use this register to store or copy data into the register by using data copy instruction. Now accumulator. The accumulator is a 8-bit register that is a part of Arithmetic Logic Unit ALU. This register is used to store 8-bit data and to perform arithmetic logical operation. The result of an operation is to store in the accumulator. The accumulator is also identified as a register A. Now let's talk about flags. The ALU include 5 flip-flops which are set or reset after operation according to the data condition of the result in the accumulator and other register. They are called as 0, which is denoted by the sign Z, carry CY, sign S, parity P, and auxiliary carry AC. The most commonly used flags are 0, carry, and sign. The microprocessor uses this flag to test data condition. So at the bottom of the figure, we found the 16-bit register, the program counter PC, and the stack pointer SP. So first let's talk about the program counter PC. This 16-bit register deals with the sequencing the execution of instruction. This register is a memory pointer. Memory location have 16-bit address buses, 16-bit addresses, and that is why this is a 16-bit register. The microprocessor uses this register to sequence the execution of the instruction. The function of the program counter is to point the memory address from which the next byte is to be fetched. When a byte, which is known as the machine code, is being fetched, the program counter is incremented by 1 to point to the next memory location. Now stack pointer PC. The stack pointer is also a 16-bit register used as a memory pointer. It points to a memory location in R by W memory called the stack. The beginning of the stack is defined by loading 16-bit address in the stack pointer. The diagram you all are seeing on the screen is the full 8085 microprocessor architecture. We have already discussed each component present in this diagram. So the major application of 8085 microprocessor is that 8085 finds its major application in programmable calculator as well as in a numerical control and environment monitoring systems. These are also used in switching, banking, and financial system. So I hope you all liked my video. Thank you so much.